Good morning everyone. Today we are going to see the topic query processor. Query processor components includes DDL interpreter, DML compiler. So now let's learn about another important component of DBMS called query processor. Whenever a user writes an SQL query, the query processor is responsible for understanding and executing it. The query processor consists of three main components: DDL interpreter, DML compiler, and query evaluation engine. The first is the DDL interpreter. It interprets data definition language commands such as create, alter, and drop. Whenever a table is created or modified, the DDL interpreter updates the data dictionary with the new information. The second component is the DML compiler. It converts the SQL queries into low-level instructions that the computer can understand. It also performs query optimization, which means choosing the fastest and most efficient way to execute a query. The third component is the query evaluation engine. After the query is optimized, this component executes the instructions and retrieves the required data from the database. So in simple words, the query processor understands the query, optimizes it, and produces the final result for the user. So next one is query processing. So there are three stages of query processing. First stage is parsing and translation. When we write an SQL query, the system first checks whether the query follows the correct SQL syntax. If there is any mistake, such as a missing keyword or incorrect table name, the database displays an error message. The second stage is optimization. Here the database searches for the best execution plan. If there are multiple ways to retrieve the same data, it chooses the fastest one to reduce execution time. The third stage is evaluation. Finally, the optimized query is executed, the required data is retrieved from the database, and the results are displayed to the user. So every SQL query goes through these three stages before we see the final output. So next one is transaction management. A transaction is a group of database operations that are treated as a single unit of work. For example, when transferring money from one bank account to another, two operations are involved. First, the money is deducted from one account. Second, the same amount is added to another account. Both operations should happen together. If one operation fails, the other should also be cancelled. This is the responsibility of the transaction management component. It also protects the database during unexpected situations such as power failures or system crashes. Another important responsibility is concurrency control. Many users may access the database at the same time. The concurrency control manager ensures that multiple users can work simultaneously without causing incorrect or inconsistent data. Therefore, transaction management ensures that the database always remains accurate, reliable, and consistent. Now let's study the different database architectures. A centralized database stores the entire database on a single computer or server. All users connect to this central system. This architecture is simple and easy to manage, but may become slow if many users access at the same time. The second type is client-server architecture. In this model, the database is stored on a server while users access it through client computers. This is one of the most commonly used architectures in organization. The third type is parallel database. Here, multiple processes work together to execute database operations. This improves speed and performance, especially for very large databases. Finally, we have the distributed database. In this architecture, the database is stored across multiple locations connected through a network. Although the data is distributed geographically, users can access it as if it were a single database. Each architecture has its own advantages depending on the size and requirements of the organization. So it shows the architecture of centralized database system. In a centralized system, all the data is stored on one central server. Users from different departments connect to the server through network. Whenever a user requests information, the request goes directly to the central database server. The server processes the request, retrieves the required data, and sends the result back to the user. The advantage of this architecture is that data is stored in one place, making backup, maintenance, and security easier. However, there is also a disadvantage. If the central server fails, all the users lost the data access to the database until the server is restored. Therefore, centralized databases are mainly suitable for small and medium-sized organizations. So next one is database applications. Database applications are usually partitioned into 2 or 3 parts. In a two-tier architecture, the client application communicates directly with the database server, For example, a desktop application installed in an office directly connects to the database and retrieves the data. In three-tier architecture, an additional application server is placed between the client and the database. The client first communicates with the application server. The application server processes the request and then communicates with the database server. This is the two-tier and three-tier architecture. This diagram compares the two-tier and three-tier. On the left, you can see the two-tier architecture. Here, the client communicates directly with the database server. On the right, you can see the three-tier architecture. Here, the client communicates with the application server instead of directly accessing the database. The application server performs tasks such as user authentication, business logic, and request processing before communicating with the database. So today we discussed the query processor, query processing step, transaction management, different database architectures, centralized databases, and the comparison between two-tier and three-tier architectures. Remaining we will see in the next class. Thank you.